Welcome to C Programming Tutorials. In today's tutorial, we are going to learn about um, pointers. Pointers is a very interesting concept, very powerful concept, and it's kind of an advanced topic here. So we have covered pretty much quite a bit of stuff already in the previous tutorials that we can go and start talking about pointers now. Again, if you haven't watched the other tutorials, I would recommend that you watch them, and please make sure that you become the fan of the Facebook page Advanced C Programming Tutorials in High Def if you haven't been already the fan of that page. And I would also recommend that you become you subscribe to the channel Learnorama so that you can be notified of any new video tutorials as soon as I post them. And also, I would really highly appreciate if you could give me some feedback as to you're liking the videos or not liking the videos, or if there are any suggestions for improvements or any topic that you want to cover. I would really appreciate that also. That way, I know that there are people out there who are watching the tutorial and learning from it, and care about it. So anyway, so let's get started with the pointers. So pointers. Now, before we start with pointers, again, we need some kind of background information, and that would be the information about how the memory is laid out in a computer. So it's pretty common concept, but if you don't know about it, it's going to be very hard for you to understand the pointers. So let's understand the logical view of memory. Okay, so let's see. Memory in computer, every computer has some memory. By definition, it has to have memory where it stores the data and stuff. Your computer has memory, and this is how you can visualize it to be logically. The memory looks like this. It's usually the memory is huge. Okay, so think of it as having as being basically let me use lines. Think of it being a collection or a sequence of bytes. And what is a byte? A byte is basically simply 8 bits. Okay, and what is a bit? A bit is basically either 0 or 1. Is the location, the minimal location where you can store 0 or 1. But memory is a collection of bytes, and each byte has 8 bits. You can access individual bytes, but you cannot access, even actually in all the modern computers, you cannot even access individual bytes. You can access only 4 bytes, a D word at a time. But the minimal you could access in any processor would be a byte. Okay, you cannot access the individual bits in it. So if this is the view of the memory, if you are looking at the memory right here, these are individual bytes in that memory. Okay, and basically what memory is simply a collection of large number of bytes. Okay, huge number of bytes here, like this, something like this. Okay, and each byte has an address associated with it. Address tells computer where that memory location exists. Okay, it's simply a number, and it basically starts from 0 for the first byte, and then 1, 2, 3, 4, 5, 6, 7, and so on, all the way to, if you have n number of bytes, you must have heard your computer has like 4 gigabyte of memory. Okay, so you have 4 gigabytes of this. 4 gigabytes, 4 gig is actually 1024 multiplied by 1024 multiplied by 1024. That's what makes a gig, which is the same as 2 to the power 30. Okay, that's a big number. It's roughly equivalent to approximately equal to 1 billion. So 4 gigabytes is like 4 billion bytes. So this would be like 1 less than 4 billion, and last address n minus 2, n minus 3, n minus 4, and so on. Okay, so this is the view of the memory. Okay, now and each memory has an address associated with it. To access a particular address or the value stored in that address, you use the value stored in that location. You use its address. Okay, so when we basically when we write in our C program, when we write int x, what happens at this point? What happens is the computer allocates a memory, or the operating system actually allocates the memory somewhere, memory for this variable x, and integers are basically 4 bytes long. So this variable x is actually 4 bytes long. Okay, it is 4 bytes long, so it allocates 4 bytes for it. So say for example it allocates these 4 bytes for it. Okay, these 4 bytes right here. Okay, and calls it the variable x, and actually x represents this address, the start of this 4-byte location, which is start address of this 4-byte location, which is 4. Okay, so actually x represents the value stored in it, but the address of x is, in this particular example, is 4. Okay, so later on in the program, if I say x is equal to 20,465, for example, okay, what it does is, at this point, when it runs this statement, when it executes this statement, what it does is it writes 20,465 in all these 4 bytes together, combined together. Okay, in this 4-byte location it writes 20,465. Okay, so this is the value of x. So x represents, x is the same as the value of x. Okay, now there is an address associated with the x also. And how would you access the address of x? How would you know what the address of x is? There is an operator called ampersand. So in C program, if you write ampersand x, what this means is the address of the location where the x, the value of x is stored. Okay, so x means, in this particular example, it is same as 465. Okay, but ampersand x is the address of x, which is in this particular example 4. Usually addresses are also very huge. They are not like 4, 5, 6, because in the beginning of the memory is already filled up with special things. Okay, so when by the time your program runs, you know, all this memory is already filled up, you get to run somewhere in the middle of the memory, and this address is huge number. It's not a small number, but just for our example's sake, we are thinking that the address is 4. Okay, so ampersand x represents the address of x, and which is 4. Okay, now in C, there is a concept of pointers. Okay, pointers are basically, as the name suggests, they point to memory locations. Okay, they can point here, they can point here, they can point here. Okay, and how do you declare a pointer? This is how you declare a pointer. You write the type, then you write the star, asterisk, you know, the character which is on top of the 8. When you shift 8 will print this thing, you know, will display this thing, and then the pointer name. Okay, so for example, if you want to declare an integer pointer, you say int pointer px. Okay, you can name it anything you want. Okay, I tend to write p before some name, whatever name I choose. I write p so that I can, just by looking at it, I know that it's a pointer. Okay, and then if you have a variable called x, you declare it like this, and then what you could do is you could say px is equal to the address of x. Now remember, pointers can take the values that pointers take are the addresses of the memory location. Okay, so you can say px is equal to address of x. Okay, and what it would mean is that the value of px, now think of the visualized pointers like this. Okay, let's stop here and let's continue this tutorial in the next video, because I am running out of time. Thank you.